Okay, so today I'm going to talk about practical static analysis. And the one-line reason for this talk is that by the end of this talk, well, I believe that appropriate application of static analysis reduces the overall cost of software development. And hopefully by the end of this talk, you'll agree with that statement, and you'll have some tips in how to apply static analysis to your workflow. So if we imagine this is how much a bug costs, generally the later we find a bug, the higher the cost associated with fixing that bug. And how static analysis will help us is we'll hopefully we'll find a bug. Instead of it going all the way through to maintenance, we'll find it far earlier on in our development process and potentially not even introduce it in the first place. So the agenda today, we'll quickly look at what static analysis is, then we'll look at some basic static analysis, and we'll go on to the more advanced stuff, and we'll see how to apply that practically. So let's have a quick look at what static analysis is. So we can do some static analysis now. We can ask ourselves, is this code correct? So let's have a look. We can see we're assigning the integer value 1 to the variable a. We're then calling process passing that integer value 1. And we can see that process takes some parameter, but we don't know what. So looking at this code, as far as we can tell, this code will work. But what about this code? So again, we assign the integer value 1 to $a. We call process. And this time, we can see that process expects something of type user, which integer value 1 isn't. So we know, therefore, that there's a problem. So static analysis will tell us that our code is incorrect. And this is very simple static analysis that we've all done, but some of these tools can do some quite clever analysis. So static analysis answers a slightly different question to testing. So imagine we have this very simple method of a function called getPrice. It takes a type, which is a string, and it returns an integer value. So assuming we pass in the string child, we're saying the price is 10. And if we pass in the string adult, we set the price to 20, which we then return. So if we wanted to test this code, we could have a test case that looked like this. The first test case, we put in child, and we're expecting 10. And the second test case, we put in adult, and we're expecting 20. So if we look at how the code is written, and given those test cases, all our tests would pass, and we'd also have 100% code coverage. And also both our decisions, we'd have taken both the true and the false branch for that. So tests tell us that for a particular scenario, everything is working correctly. But they only assert that things are working correctly for the particular tests that we run. So static analysis would look at this same code base, and it would say, well, I think there's a problem here. Possibly price may not be defined. It might have been set during that method. And we're trying to return an int, so this clearly wouldn't work. So static analysis tells us that our code is incorrect, and tests tell us for that particular scenario that the code is working correctly. So you kind of need both. So let's look at some very basic static analysis. The first thing we'll look at is linting. So linting is just looking at your code for syntax errors, like a misplaced semicolon or a missing close brace or something like that. If I want to do this on the command line, then I use a tool called parallel lint. So that's how I install it, and then to run it, I just call parallel lint with all the directories that I want it to lint. And because it does it in parallel, it's reasonably fast. So that is the bare minimum of static analysis tools we want. We can also have tools that check our coding standards, for example, things that comply with the PSR standards, for example. There's a couple of tools. One is PHP CS Fixer, which is one I use. There's also Code Sniffer. They both do very similar things in terms of looking at the code and checking it conforms with a particular coding style. It can also do slightly more advanced stuff, like saying you must always use like treble equals rather than double equals. And a lot of the issues they find, they can provide auto fixes for. So not all of the issues, but a lot of them, certainly formatting, they can automatically fix. So they're great tools for making sure you have consistent code across the team. Another good tool to use is the Sensio Labs security checker. What that does is it looks at the composer.log file and then cross-references a database of all of the known security vulnerabilities and reports if any of them are marked against a package that you're using. So you'd want to use the security checker every time you commit your code, but this is also something that you'd want to run every day because new security vulnerabilities might get found out. So typically I set my CI to run every day just to doing the security check. And there are other checks. Only in the past year have I added this into my CI process, the composer validate, to make sure that both the composer JSON and the composer log file are in sync with each other. And it does some other checks too. So that's a really useful one. Things like var dump checker, just to make sure I haven't left var dumps in my code, maybe from debugging. And if you were to Google PHP static analysis tools, you'll find this page here, and this has got probably hundreds of tools on them, and lots of them are fantastic tools to use. So I'd get the basics in, and then maybe start looking at other tools that might be useful for you. If you use Symfony, then there's some nice linting in here. There's one to lint all your twig, your YAML, and there's also one for validating that your doctrine schema matches up with the database. So, and there's many, many more. So my starting point is, if I want to make sure these get run in CI, then the one way we can do it is using composer scripts. So you can just add to your composer JSON a part called scripts, and within that I have something called CI, and then that runs all of the individual parts of my CI, all the individual static analysis tools. And that means there's just a single script that I run, and as I add in more tools, I don't have to change anything. The other script I'd recommend adding to your composer scripts section is CSFix, and that calls the coding standards fixer tools. And this again means if you switch fixes or you add in new fixes, all you have to run is composer run scripts CSFix. And you don't have to use, there's other ways, you could use a Fing script or other ways or a bash script of doing this, but the composer scripts is just one way of doing it. Now, I'm not going to talk too much about CI. I mean, ideally all this would get run every time you commit, but also you definitely want to run this every time you push your code up to your CI server. I have no association with Circle CI other than I use it. And it gives you 1,000 free, at the moment, it gives you 1,000 free build minutes per month. So if you're just starting out, it's a cheap, it's almost free way of doing things. And I'm not going to go into this code, this configuration, but it's something like 16, 17 lines of code. And with that code, you can run the most basic static analysis tools we've just talked about. And if you really want to have a look, go to that GitHub link, and that takes you to an example of it. So my point really is, it's very simple to get to this stage where you're running simple static analysis every time you commit code and push it up to your CI server. And if we think about our cost of the bugs, the best we can do with CI is moving it down to the point where our CI is actually run. But we can do better than that. I'm always unsure as to whether I need these slides or not, because I think what happens is I still meet people who are not using tools like PHPStorm or similar. But if you're one of those people who is still using a text editor or not a very advanced IDE, then I suggest having a look at these tools. Again, I have no association with any of them other than I use them. But your requirements for a tool to do the real-time static analysis, so it highlights issues as you're coding. Your requirements for this tool, it needs to understand the entire code base. They need to be able to highlight errors in real time and maybe suggest an autocomplete as well, and also help you with refactoring. So you don't have to use PHPStorm, but whatever tool you do use, make sure it ticks off at least all of those points on the tick list. And they're so important because as you're coding along, it highlights the error, and we can see this is from the second example. It's just telling us in real time that there's a mistake. So I'll fix it there and then. And actually, that probably stopped me making mistakes in the first place, because as I type, it's aware of the context of everything, so it suggests the only possible correct answers in a lot of cases. So it stops me even putting bugs into my code. So if we think about the cost of our code, we can reduce using real-time static analysis to the point where we're actually writing code. We can get bugs all the way there. So there's a big cost saving. If you don't use an IDE, then PHPStorm, you can get a 30-day free license, use it, and then at the end of those 30 days, go into the help menu, click on the productivity guide, and it tells you some stats. So for me, it tells me it's saved me writing 1,300 characters every day. Every working day, I'm not typing over 1,000 characters. And it also tells me that since I've used this, it's saved me 783 possible bugs, which is 12 a day. So just imagine that. How much do those 12 bugs cost? Probably quite a lot. Probably a lot less than a PHPStorm license. So there you go. So this is where I was for quite a long time with my static analysis. I was using a real-time static analysis tool, and I had the backup of everything working in Circle CI as well. So I'm going to talk now more about the more interesting bits, the advanced static analysis. And I kind of had this nagging problem. The real-time static analysis that was going on in PHPStorm was really powerful. It was far more powerful than anything I had in my Circle CI. So if I saw a bug whilst I was writing code, that was fine. My IDE would tell me that there's a problem. But there was no safety net. There was nothing to, if I missed something, or maybe I made some code here, made a change to code here, and that affected something over there, and I wasn't aware of that fact. There was no safety net for that. So I had my real-time static analysis, but my CI was a bit lacking. And I think it was about 2 years ago, I went to a talk, and someone was talking about a tool called Phan. And I did a bit of research, and I thought, this is exactly the tool I want. And it turns out that there are 3 very similar tools. There's one called Psalm, one called Phan, and one called PHPStan. And now I'm going to look at kind of an overview that's appropriate to all of these tools. And then we're going to dive a bit deeper into Psalm and look how you can do some quite powerful things with that. But what you can do with one, you can generally do with all of them. So the first thing is you could go to the Psalm homepage, and you can try it out there and then. You can type some code in, and it pretty much tells you in real time the issues it would find. And actually, it finds a lot more issues than PHPStorm does out of the box. So it's great, you can have a play with it. PHPStan has a similar tool on its homepage as well. So there's some common concepts between all of these tools. They all have a concept of levels, going from least strict to most strict. Every time you add in another level, then there are more and more rules, and it becomes stricter and stricter. So to get the best out of these tools, we need to type hint everything. From that example earlier, just by adding the type hints, we can see that we've made a mistake. So if you're going to use these tools, then you want to go through your code base and start adding in type hints if you're not already. However, there is a limitation in the PHP language at the moment in that generics aren't really covered. So if we look at this code, we can see we've got a for each loop, and it's looping around the response from getEmployees. And we can see that getEmployees does return something iterable. It returns an array. So we have type hinted getEmployees, which is good. But there's no way of saying what is in that array. So we don't know what employee is. So we're calling promote passing employee to it. And we cannot say for sure whether the thing we're passing to promote is actually of type employee. So there's a way around this, and you've probably seen this kind of notation. So what we can do is, instead of saying in the dot block, instead of saying we're returning an array, we can say we're returning employee, open, close, square brackets. And what that means is we're returning something we can iterate over, and each of the values is of type employee. And what Psalm will do is it will look inside that function, and if you ever try to add something which isn't an employee to the array that it returns, it will flag that up as an error. So this means that we now know that employee in the for each loop is actually of type employee. So the thing we're passing to our promote function is an employee, so we know that this code is all correct. So adding that in has helped, and the great thing is that my real-time static analysis tool also understands this convention. So you can see here that we've got something of type employee, which is an array of, well, something you can iterate over of type employee, and it's clever enough to see that actually this employee in the for each loop is actually of type. Sorry, the variable employee is in type employee. So that's great. However, what if we wanted something a bit more advanced? So now we're iterating through the response from the return from getEmployees, and we're getting both the key and the value. So the key is the variable name, and the value is the variable employee. We're then going to pass name to the welcome method, and we could see that welcome method is expecting it to be of type string. Now, with the information we have here, we don't know that we don't know what the key is. And if we put this code through Psalm, it would give us this error, and it would say, I don't really know what name is. If Psalm doesn't know the type of something, it says it's type mixed, and here it's saying, I'm expecting argument 1 of welcome cannot be mixed, it's expecting a string. So it's telling us it's seen something that is a problem. So what we can do is we could write our return type like this. So we're going array, open angle bracket, string, comma, employee, close angle bracket. And what that means is that means the array we're returning, the keys are all of type string, and the values are all of type employee. And again, Psalm will look at what's going on inside getEmployee, and if we ever try and make an array where the key is not of type, if we ever try and add something to the array we return where the key is not of type string, it will tell us that. But also it means we know that name down here is of type string, so when we call welcome, we're calling it with a string. So that's all great. The problem is, however, and I think this is still the case, the tool I use doesn't understand this terminology. So here it is. It doesn't know that employee is of type employee. It now says it's mixed, so it doesn't know what this is. Now, if I had the choice between real-time static analysis being correct or this kind of static analysis that I do later, I would always want the real-time static analysis to be correct, because that is what is most useful to me. Fortunately, it's not a choice we have to make. What we can do is we can leave in our return type, our annotation that says @return employee, and Psalm understands that, and PHPStorm understands that. we can add in this extra annotation called psalm return, and this is in the format where we actually give the extra information about what the key is in the array. And my hope is that this format for generics will become part of maybe PSR 5. I know it's just been taken out. But if we could, as a community, come together and say, this is how we want to represent generics, we have tools like Psalm, and if our tools like PHPStorm could also understand this, then we can essentially have generics now. I mean, not at language level, but we can have it checking with our CI, so it's as good as, pretty much, is as good as having generics. So it is quite exciting. We just need to agree on this, and the tools need to implement it. So Psalm has things like Psalm var, Psalm param, and Psalm return, and what that means is it will ignore the normal var, param, and return methods, and it will use what it sees there. Phan has something similar as well. And the other common concept between all of these tools is, as we looked at earlier, they all have this concept of levels. You can often annotate the code to say, this is an issue that I don't want you to report. And they all are quite configurable in terms of you can ignore certain directories, you can turn off certain kinds of errors. And some of them you can even say, I don't want to hear anything about this kind of error within this directory. So hopefully you're thinking, this tool sounds amazing. How do we get started? It's quite simple to install. You can just do compose require. All the tools have a config file where you give information like what rules it has to run at and where it can find the code. And to create the Psalm config file, you just use the --init option, and then you run it. And probably, if you've got a code base of any real size, you'll probably cry when you see the results because it finds quite a lot. So these are the results it was a relatively small project, but on Psalm's most strict level, it still found 1,500 issues. And what you start doing is you look at the kinds of issues it finds, and you start asking the question, well, what really is a bug? Because a lot of these things you think, are they really bugs? So I'm going to say there's 4 kinds of issues that Psalm, all of these tools find. You can categorize them in 4 ways. The first is genuine bugs. This is code that if you ran the code, you would get an exception. Something would go wrong. Then you've got something which I'm calling a deferred bug. This is not a bug now, but it could be a bug in the future. You've got evolvability defects. That's just a posh word for technical debt. And you also find false positives as well. So these are things that they report as bugs, but they're not actually bugs. So this is the example of a bug. We're passing in an integer to something that expects type user. So the code we saw earlier, I'd say this is a deferred bug, because there's a chance that sometime in the future, somebody will call getPrice, and it will be with a value that isn't child or adult. And the kind of question you get is, are these deferred bugs really bugs? And often, it's easier to come up with some kind of fix than to argue as to whether these are genuinely bugs or not. So often, it's quicker to fix them than to not. So the third type is an evolvability defect. And that is code that makes the code base less compliant with standards, more error-prone, or more difficult to modify, extend, or understand. So it's a posh word for technical debt. And the interesting thing is people have done studies on evolvability, and they've looked at lots of people working on code bases, and they found things that low evolvability code actually costs real money. This isn't a surprise to us developers, but I've linked, there are links, if you get my slides, that the final slide actually links off to the studies where they've done this. So, it's taking 28% longer to implement code on poor quality code, and bug fixes take longer. And there are studies that back this up, which is good if you want to take them to management. So a kind of evolvability defect here. We're saying the return type is int, but actually when we look at the code, it doesn't really look like it's returning an int. It looks like it's returning a string. So these are 4 types of bugs. I think we'd all agree that a bug, traditional bug, something that will cause an exception to be thrown if the code runs, is definitely a bug. I'd also argue that deferred bugs and evolvability defects are also bugs or issues that should be resolved if they can, because there will be costs associated with them, if not now, certainly in the future. And often, even false positives, what you can often do is rewrite the code in a different way such that the static analysis tool doesn't complain about it. And often the way you have to rewrite your code is a cleaner and more understandable way of writing the code anyway. So you can, if you're very careful, get to a stage where you don't have any or very few bugs reported. And at the times when you really need to ignore a bug, I just use an annotation to say just ignore this, this particular issue. So on the code I ran, here was an example of one of the real bugs it found. We can see we've got this method, getEmailaddress, which returns something of type string. So working back in the code, we see that we're returning something of type, returning a variable called email. And we're pulling the email out of an array. And this particular array was something we got from an untrusted source. So we haven't really done any validation on it. We've got some validation. We make sure that that row does exist. But maybe the JSON data structure had something in there like, instead of an email, it was a number or something else, something that isn't a string and certainly doesn't represent an email address. So I was almost there with this implementation, but there's still this kind of code that I've highlighted here needed to be extended to make sure that email really is of type string. This was a deferred bug that we found, and is something that could catch us out in the future. We are calling a method createSearchTerm, and we're passing a postcode and the location getSlug, the response from that. We can see that createSearchTerm is expecting of something type postcode and something of type string. So what does location getSlug return? Oops, wrong way. Sorry. What does location getString return? It returns either a string or possibly something that's possibly a null. So the problem with this is we're expecting createSearchTerm to only accept a string. It cannot cope with a null. So there is a chance sometime in the future that maybe getSlug will return a null. So I'd have to look in this code and see, can we enforce it so it always returns string? Or if there's ever an occasion where it might return null, then I'm going to have to go and look at this code to make sure that that null can be coped with throughout. Working fine now, but who knows in the future when we extend the code further. An evolvability defect here. Actually, I learned something. I, at the time, didn't realize you could put a return type for an anonymous function. Again, this is better code than without the return type because it's giving information not only to the tools, but also to other developers about what's expected. Even so, these tools can produce a whole load of bugs, and are you really expecting me to fix all the issues it finds before we do any future work? And the answer is no, that's not realistic. So let's look at some things we can do in practice to help when we integrate these advanced static analysis tools into our workflow. The first thing, if we think about code, often we've got some kind of framework. And then we've got, hopefully we've developed our code so we've kept the business logic, which is the real value code that we're really interested, as separate from our framework as possible. And we can probably we should apply quite strict static analysis to our business logic, but we can care less about our framework. And if we're using frameworks like Symfony or Laravel, they're pretty well tested. We're probably okay. They probably work fine. So we definitely want to target most of our strictest static analysis to our business logic. Another problem we had in the code was sometimes when you're integrating with third-party libraries, especially if they're a bit old or they're written in such a way where they're not kind of set up that well for static analysis. So I was using this third-party hasher library, and you could give it anything to the encode method, and it would return a hash. In the cases I'd always be using it, I'd just be passing the ID of an entity. But if we look at the signature of this, it looks like encode doesn't take anything at all. Actually, it can take any number of arguments, and it just does something clever to get the hash. But this is not obvious necessarily to me, and it's certainly not obvious to the static analysis tool. So it would flag this up as an error. So what we could do is write an adapter called clean hasher that has a instance of the actual hasher which we inject via the constructor. And then we have a clean method for encode, which we're just mandating that we're just taking one thing, an int, which is the ID, which it then calls off to the actual hasher. So there would only be one case where we have to just say to static analysis tool, just ignore this, it's fine. And our static analysis tool will be checking now that every time we call encode, we are passing an ID, an integer, which is the use case we had for it. So other things, maybe we've got a class called foo with a single method called say hello, and we've got our dependency injection container, and we pass to it the dependency injection, the name of the class we want it to construct, and it will return one of those objects. So typically we use the code something like this. We'd ask our DI container to make something of type foo, and it will return a new instance of foo. And we know, we as humans can look at this and we can say, well, this is safe to call say hello because we know we're talking of type foo. It exists. But our static analysis tools don't know that. So there are a few things you can do. You could tell the tools that foo is of type foo just by using the annotation, the @var annotation. And that means tools like PHPStorm and Psalm will understand now that foo should be of type foo. But the problem is, what happens if somebody does something like this, and let's just say foo isn't in the namespace my app. So we've passed in a string, but actually that string doesn't really refer to the object foo. So we can improve things. In Psalm, we could change the signature of our DI container to use this. Instead of saying I'm expecting it to be a string, we could say this class-string. And what that means is Psalm works out what string you're passing to the make method, and it makes sure that it actually represents a real object. However, there's still another problem. What happens is if we update what we're asking our DI container to make, but we don't update the doc, we'd be in trouble. And again, Psalm offers a way around this. So this is kind of an advanced generics concept. We can say we've got this thing template T. So this means at the time we're writing this, we don't know what T is. But when Psalm does its analysis, it can say we're saying that T is whatever the type of class name that we put in. And then finally, we can say, and we are returning something of type T. So this is really powerful because that allows a lot more static analysis, and it protects us against all the issues I've shown you so far. So other issues, let's say we have something that follows the command pattern. Say we would construct the object, we would then execute it or pass it off to something else to call the execute method. And then after it's been executed, we might interact with it, in this case via the getAccess token. So if we use the object in this way, this is not correct. We're calling login command, and then we're immediately asking it to get the access token. But that probably won't have been set up because we haven't run execute. And imagine we have our access token as a private member data, or we say it's of type string, And then, so the first thing that will happen is Psalm will complain about that, because unless we set access token either in the constructor or where we define access token, it could also be null value. So the first thing we have to do is we have to say access token could be string or it could be null. So then the implementation of getAccessToken is I'm just returning this access token. And the problem we have here is we are saying I'm going to return a string. But there is a chance access token, the private data, might be null. So we can make Psalm happy by adding in this extra code here, and it's just this check. And it's clever enough to look at this check and say, well, if access token is null, then I'm throwing some logic exception. So I never get to the return statement. And we might want to rewrite this. Instead of having those if statements, maybe we just write an assertion method called assert not null. And we say, we're expecting the access token to not be null, and here's a message if it is null. And the message would probably be, you've called getAccessToken, but you haven't called the execute method first. So again, Psalm is clever enough. If our implementation of not null is something like this, where we look at the expression and then we throw an exception if that exception is not met, Psalm is clever enough to know that's what's going on in here, and it will all work fine. But let's say we refactored our assert method, so we have many assertions, and they all call assert true. So functionally, nothing has changed, but Psalm isn't clever enough to go through 2 levels to see what's happened. So what we can do is we can give additional information to Psalm in this thing called a Psalm assert. And what this means is this method, if it executes successfully, expression is not null. And you can do all kinds of things where you've got the not null, you could have strings, you could assert it's of a type of an object. So that's really useful if you have assertion libraries or code that does things and will, exit if a condition isn't met. And you might say, well, that's all very well, but I'm not going to rewrite my own assertion libraries because there are perfectly good assertion libraries out there, like WebMozart assert. So how do I get Psalm to understand these other third-party libraries, especially if those third-party libraries don't have the Psalm-specific annotations on them, and it's fair enough that they don't. So what we can do is we can make a stubs file. So we can make in the stubs directory, we could have a file called assert, and it will be the same namespace of whatever it is that we are providing the stub for. And you have something that matches the signature of the method that you want to provide additional information for, and you put in, just on this thing, the Psalm assert. So Psalm now understands that not null will exit if you pass it a null value. So stubs are really, really important when you want to interact with other third-party libraries that may be written in such a way that they don't have enough type hinting information, or they don't have information like this about the functionality of it. And in Psalm, it's just part of the config file. And also, you can make plugins and then share them with other people. So it means if one person goes through and they write a plugin for the assertion library, for the WebMozart assertion library, all the other developers can just use that instead of rewriting it. And people have written plugins for things like Symfony and Doctrine and stuff like that. So the key message is, when you start using these tools, you need to learn from the mistakes. So look at the issues it's raised and modify how you program your code. Type hint everything, including generics in the ways we've discussed. And if you need to do anything more, then you can use the plugins or stubs to give additional information to the static analysis tools. And there are also tools out there which help auto-fix issues. So maybe some of you went to the talk this morning about Rector, and that can look at the similar kind of issues. Those are the ones that static analysis tools find and can auto-correct some of them. Psalm also has something called Salter, which also automatically corrects things. It looks through the code and says, I'm pretty sure I can add in those type hints and stuff like that, or fix them manually. But even if you do all this, you might still have a code base where there's thousands of issues, and it's not realistic to start writing new code. It's not realistic to fix all these issues before you start writing new code. And this is kind of the next evolution where people are trying to write things to help with baselining static analysis tools, with static analysis. So you take your code base, let's say you find a load of issues, you fix all the ones you think you have to fix, and you're still left with thousands of issues that one day, hopefully, you'll go back and fix. But you want to make sure that going forward, you don't add any more issues. So we say, here are all my issues at my baseline. We write some more code. We rerun the static analysis tool, and we have a load more issues. Maybe we fixed some of the issues that were previously there, but we've introduced a new one. And all I care about is what is this new issue that has been introduced, because I want to make sure that although my code has a number of issues, I don't want those number of issues to increase. So I only want to see the new issues I've introduced since the baseline. So there is a tool called SARB, Static Analysis Results Baseliner. You can find it there on GitHub. Currently it supports SARM and PHPStan, but you could actually add in adapters to work with other static analysis tools. It does require that the code you're analyzing is in the Git repo. And the way you'd work on it is you would run SARM on your code, you would then do SARB create baseline, and you pass it a series of locations of where various files are. And it would say, okay, baseline's created with however many issues you are having in your baseline. You would then update your code, you'd rerun SARM, you'd rerun SARB, and it would give an output like this, and it would say, and by the way, since the baseline, there's 15 new issues. And those would be the ones you'd focus on and fix to make sure that your code base doesn't get any lower in quality. So you're maintaining a level of quality. So very quickly, how does it work? What it does is it keeps, when you create the baseline, it knows the git commit that the baseline was created against, and it has a list, and it knows what it was created with, so SARM in this case. And it has a whole list of things saying, this is the type of the error, this is the file, and this is the line number. So you might have your code like this, and you've got this issue here on line 93, invalid nullable return type. And then you might go on and you might do some more coding. Maybe you rename person and call it employee, and you remove 20 lines of code. You rerun SARM, and it now says at line 73 of employee, we've got this invalid nullable return type. So what happens is SARB first of all says, well, I've got this problem, invalid nullable return type, at line 73 of employee. It says, what was the location of line 73 employee when the baseline was taken? And the history analyzer with some Git magic says, that was line 93 of person. And then SARB says, great, well, did we have a problem, invalid nullable return type on line 93 of person in the baseline? We look at the baseline, we see we did. So we can see that this is a problem that was in the baseline, so let's not report it as a new issue. And if any of those things were not true, then this means that this is a new issue that's been added. So this is something we need to report. So the static analysis with a tool like SARB, we would run our static analysis tool, we'd fix all the bugs we decide need fixing, we would rerun the static analysis tool again, we would create a baseline, and then from that point onwards, we'd repeat forever, we write some code, we run the analysis, we remove the baseline results from the latest analysis, and we fix the new introduced bugs, and hopefully we'll be happy. At the time that tool was being written, SARM actually came up with its own baseline, which is far simpler in implementation. And if you're using SARM, definitely look at it. When you run SARM, you can set a baseline file. And what that does, it's slightly more complicated than this, but it keeps a tally of all of the types in the file. So it says, well, in file person.php, we had 3 issues of invalid to nullable return type. And then you got your baseline, you run some more code, and then on the later one it says, well, actually, I've now found on this latest one, our new count is 4, and at the baseline we had 3, so it'll say, look, there's probably a new issue that has been introduced here. So it's quite neat how it does it, and it is actually slightly more clever than that, so the chance of having a duplicate, thing is unlikely. It's quite a good way of doing it. So our journey through static analysis, we kind of looked what it was. We looked at the very basic stuff, and then we've looked at the more advanced things and how to put that into practice. So this was what I was saying at the start, that I believe appropriate application of static analysis will reduce the overall cost of software development. And the reason it does that is because we're taking bugs potentially in the future and moving them to the time we're writing code, or maybe not even introducing them in the first place. Make sure, by the end of the next working day, so by the end of Monday, if you haven't already got a tool set like this, I would add this in. You can set up the composer scripts, you can add in all these basic static analysis tools, and you can put them in Circle CI, and that's less than a day's work. So if you're not there, definitely make that a priority, because it's really simple, and it's really simple to implement, and you've got like all this extra safety net that you wouldn't have had before. Make sure you're using some kind of real-time static analysis tool. And can do all these things. I use PHPStorm. Again, if you haven't got that in place, this is something you can sort out the next day you're in work. And once you've got all that in place, then start looking at using some advanced static analysis tools, things like SARM or PHPStan. So I've been Dave Liddament. Thank you very much for listening. If anyone has any questions, I've got time.
We almost don't have any time, maybe one question.
If anyone wants to talk to me later, just catch me. I love talking about this stuff, so yeah.
Yeah, and thanks for featuring PHPStorm.
Okay.
That was not paid, by the way.
Oh, yes, yeah. But you can give me some money later.
Let's have one question. Yeah. It's over there.
Pass at the back. Make it an easy question, please. Yeah.
Hello, thank you for the speech. It was really interesting. So my question is, you mentioned 2 main points when you can run your static analysis tests. It's real time in the day and during the CI.
Yes.
And sometimes you want the developer to run some tools locally before he commits his changes into the CI, because you can have tens of developers and you will have one build for each of them, and they will just run in queue, and it will take really a lot of time. So what can you do to make all developers run some tools locally, manually? Okay,
so when I say real-time static analysis, what I really mean is the IDE. So that will be, if I just have an IDE and you set it up with all the things, like you can set up, for example, PHPStorm with your coding standards. You can just take the config you use for PHPCS, and it just does that all in there. So when I say real-time static analysis, I should have made it clearer that I mean the IDE. So those would be the tools, and that's all I do. So on my team, we just use it within the IDE. The only sort of exception is we might run the CS fixing before we push the code up, because even though you can set it all up in PHPStorm sometimes, or maybe you haven't set it up properly, but sometimes you can still save your code and it hasn't applied all the coding standards bit. So my typical work process is I do all my real-time static analysis in PHPStorm. Before I push the code up, I use CSFix, and then everything else, and I'll probably run what I believe the relevant tests are. I mean, I'll run the unit tests because they're quick, and then I'll run like whichever of the slower tests are on the area that I'm working on. So by then, I'm pretty confident that my CI won't fail, and then I push it up there. So in the answer to your question, it's PHPStorm that's doing all the real-time static analysis.
Yeah, and just small thing in addition, you can use the pre-commit hooks that will run these tests locally, so you can make kind of automation of it. You
can do the, if you're having a Git hook, it can do the check, but it can't do the updates to the code because your commit won't include what you've what the tool changes. So you can have the CSFix as part of a pre-commit Git hook, but you can't have it actually doing the fix because what will happen is if there any code that changes, that won't be part of the commit that's done. If that makes sense.
Yeah. Thank you.
Okay. Right. Thanks very much then.
Thank you. We have a small gift for you.
Oh, thank you very much. Thank you.